Yeah, I'll react to that, sure. Hi guys. How are you? Good? Awesome. I hope. I sort of forget why the what was it? The Concorde, the previous like hypersonic passenger plane got cut and they stopped working on it. Clearly there was a good reason and it looks like they're getting back into it. Let's learn.
Earlier this year, United Airlines made headlines, signing a purchase agreement with Boom Supersonic to buy 15 of their future supersonic jet airliners. In what could be a bold return of supersonic travel, Boom is looking to develop the next generation of supersonic planes, building on the legacy of the iconic Concorde and attempting to address the problems that led to the Concorde's final flight on October 24th, 2006. The Concorde was a marvel of engineering, capable of flying from London to New York in under 3 hours. So fast that passengers, thanks to the 5-hour time zone difference, had to rewind their clocks 2 hours on arrival, arriving earlier than they left. Flying across the Atlantic in the Concorde was super easy, barely an inconvenience. So why did it
Pitch meeting.
stop being produced? The Concorde failed for several reasons. The Concorde had over 100 purchase agreements with major airlines of the day, including United Airlines. But soaring production costs forced everyone but British Airways and Air France to cancel their orders. Then, cramped and limited seating along with rising fuel prices made turning a profit for British Airways and Air France difficult, causing ticket prices as high as $11,000. Why fly on the cramped Concorde at that price when you could purchase a first-class reclining seat that only took 4 hours longer at a fraction of the price? At that price, the Concorde was always going to struggle to fill seats, and that just got harder after the unfortunate air crash of Air France 4560 in 2000. These economic problems were exacerbated further by the extremely limited routes available to the Concorde. Supersonic travel was banned over the United States and Europe, excluding the plane from some of the world's most valuable airline routes. The plane's range was also limited.
Out of fear of collision, because they're not used to having to factor in hypersonic planes into their I'm guessing?
Preventing it from capitalizing on routes. The plane's range was also limited, preventing it from capitalizing on potentially lucrative trans-Pacific routes. In its 27 years of operation, the Concorde's only regularly scheduled routes were across the Atlantic between New York and London and Paris. In order for the next generation of supersonic planes to succeed, they need to address these problems. And today, we're going to see how Boom is looking to prevail where Concorde couldn't. First off, those pesky sonic booms. Anything traveling over the speed of sound is going to cause a sonic boom. That's just a fact of nature. This became a major issue in the 1960s, when hearing sonic booms was not a terribly rare occurrence. With Cold War fear at an all-time high, the Air Force regularly conducted military drills near cities, and in the autumn of 1965, public acceptance of this nuisance was becoming a serious political issue.
It's crazy how just getting over supersonic speed, what is it, 700 something miles an hour, that like right under it you won't make a noise, but go right over it and you'll create this giant booming sound,
forcing the US government to form the National Sonic Boom Evaluation Office. This group then began taking measurements of sonic booms with different planes, atmospheric conditions, and flight altitudes to gauge public acceptance. They recorded boom signatures with pressure gauges and created sonic boom signatures. Here's 3 signatures, one for the F-104, one for the B-58, and one for the XB-70. We see a peak in pressure caused by the sonic boom, followed by a drop in pressure, and a final jump in pressure again caused by the tail of the aircraft. What's interesting is that we can see the signature for the XB70 is longer than the others, and that's because the plane itself is longer. The studies uncovered a huge amount about how supersonic waves travel through the atmosphere, and honestly, the entire study needs a video in itself because it's incredibly complicated and rich in history. But for now, the important thing is that people absolutely hated these sonic booms. The key word that emerged from the 6,375 interviews conducted was startling, and people did not get used to them. The annoyance only got worse over time. Many complained about physical damage to their homes, as the pressure waves could physically rattle windows. NASA is planning to revisit these tests in 2022 with the X-59, which has been designed with decades of research to minimize the pressure associated with sonic booms. With highly swept delta wings, a blunt duck-billed nose, and a very narrow fuselage that narrows over the wings to conform to the area rule. With these design considerations, the X-59 is expected to have a boom with a perceived decibel level of about 75, which the NASA team equates to the sound of distant thunder. They plan to begin testing public acceptance of this again in 2022, but critically, Overture, Boom's concept commercial plane, features few, if any, of these distinctive low boom designs and will likely have a boom just as loud as the Concorde.
So the bigger the plane, the bigger the boom, or like the bigger the kind of width, I guess. But so they have to. So the smaller the fuselage, the less the noise, but the smaller the fuselage, the less people you can carry and carry comfortably. So that's
registered
difficult.
at a perceived decibel level of 105. That blunt nose creates drag and reduces fuel efficiency, while a narrowing fuselage reduces space for passengers, sacrificing range and passenger capacity for the sake of quieter sonic booms is not an option for a commercial transport plane. And judging by the routes advertised on Boom's website, this is a problem they are perfectly aware of and are instead focusing on increased range and opening up those valuable trans-Pacific routes. So, how are they going to manage that?
I'd imagine it'd be really sought after for super rich people, who can afford, like billionaire people who, time is super expensive for them, and they're gonna want to, be places as fast as possible. So I can see there being a market for that for super rich.
Thankfully, the airline industry has been heavily focused on increasing fuel efficiency and range in the past 5 decades since the Concorde was designed, and the team at Boom will be able to take advantage of many of these advancements. The Concorde was primarily constructed from aluminium.
Sorry, question. So is a sonic boom a noise that continuously emits from the aircraft hitting the air or whatever it is? Or is it just when it overcomes the speed of sound and then it happens? Or so that's what I'm wondering, because then couldn't you have the plane go to at a lower speed in more populated areas, but only go supersonic where the sonic boom won't bother too many people, like over the ocean, or not? No? Yes?
Overture will be primarily constructed from carbon fiber composites, similar to the Boeing 787, which allowed Boeing to reduce weight and drag while creating extremely thin and perfectly sculpted wings. Bending aluminium into the perfect shape without creating stress concentrations is difficult. With composites, we have much more freedom in design. Carbon fiber also comes with the advantage of lower thermal expansion. The aluminium structure of the Concorde expanded by 0.3 meters at cruise, which had to be accounted for with expansion joints in the fuselage and hydraulic piping and slack in the critical wiring. The Overture, for the most part, shares a very similar design to the Concorde, a design that focused on minimizing supersonic drag while being capable of providing enough lift at low speed flight for takeoffs and landings. Let's compare the top view of both the Concorde and the Overture. The first similarity we can immediately spot
Everything.
is the ogival delta wings. This is a form of compound delta wing, where we have two sections to the wing, with the forward section having a higher sweep angle than the rear section. The ogival delta wing of the Concorde is a variation of the compound delta, with an OG curve connecting each section, going from concave to convex curves smoothly. This shape was used to optimize for low-speed subsonic flight and high-speed supersonic flight, creating a wing that can minimize drag.
Okay, I was gonna say I would have imagined it to have similar wings to a fighter jet that are gonna be traveling that have the slanted wings, but this is like trying to get the best combination of low speed and high speed
At supersonic speed, supersonic flight. Creating a wing that can minimize drag at supersonic speeds was vital. But these short wingspan wings create issues when taking off or landing, as the plane cannot generate enough lift at slow speeds. The ogival delta wing of the Concorde helped alleviate this by generating vortex lift, where, at high angles of attack, separated airflow would roll over the wings to form two stable cone-shaped vortices where air speeds were high and air pressures were low, effectively creating lift. This is why we see the Concorde landing with its nose extremely high, which would have completely blinded the pilot's view of the ground. The engineers of the Concorde solved this by creating a nose that could actually angle downwards on command to allow the pilots to see the runway when landing. The mechanics of this
Guys, I would have imagined that what was so strange to me on seeing a high-speed aircraft with a shiftable nose seems kind of crazy, because it just even if like you ever have like an umbrella when it's windy, or you ever hand out the car, I mean, this is going insanely fast, and I would think the front of the plane, like any sort of gap that allows air into it, is just going to rip it apart. And I would think that having this feature would make that more possible, but clearly it's not a big deal.
system,
You know what I mean?
of course, increased the weight
Like,
of
it
the
would just be
plane,
like-
required routine maintenance, increased operating costs, and the mechanism itself would have increased the overall price of the aircraft. The Overture will not feature this droop snoot, but instead use a system of cameras and
Like, what would happen if you had the drooped snoot? Is that what he said? If it was like that going at supersonic speeds. I'm not saying that it could happen, but if it lowered, I think it would be bad.
mechanism itself would have increased the overall price of the aircraft. The Overture will not feature this droop snoot, but instead use a system of cameras and screens to allow the pilots to keep their eyes on the runway even when their cockpit windows show nothing but sky. The engineers at Boom have a massive leg up in engineering tools over their counterparts at Concorde, who would have had to design the Concorde with pencils and paper while testing it in physical wind tunnels. The
People are so
computational tools we
smart.
have
Jeez.
today are absolutely mind-blowingly advanced. Just take a look at this simulation performed by NASA supercomputers modeling airflow around the landing gear of a plane. This particular
of the landing
simulation
gear,
was done to investigate ways to improve noise generated from the landing gear, and we can see these massive vortices rolling off the landing gear doors, telling us that we can improve the noise generated by focusing on airflow around these doors. In the past, engineers would have had to use low-resolution physical visualization techniques to piece together ways to reduce noise and create model after model to test different designs. Today, we can make the models in a computer and test them on a computer, allowing incredibly fast turnover times and vastly improved quantitative measurements. Tools like this will be used by Boom to land on the optimized airframe, and carbon composites will allow them to manufacture those optimized shapes with ease. On the surface, the wings of the Overture are remarkably similar to the Concorde's by all accounts, which makes sense, they worked very well. But in order to increase range, they can't just be as good, they need to be better. It's clear that Overture have made efforts to make the wings thinner while extending the delta wing further up the aircraft,
the jet engines in
seamlessly
general are
integrating into the plane's
better, more
sharp
efficient.
nose. This will all help to minimize wave drag. Wave drag
Sorry,
occurs
so the blah, blah.
extending the delta wing further up the aircraft, seamlessly integrating into the plane's sharp nose. This will all help to minimize wave drag. Wave drag occurs as shockwaves form over the plane. These shockwaves act like huge invisible air brakes, slowing down passing air significantly and increasing drag. Area ruling is one of the key methods to reduce it. The area rule is a weirdly simple rule in aerodynamics. It tells us that the ideal distribution
A design procedure used to reduce an aircraft's drag at transonic speeds, which occur between about Mach 0.75 and Mach 1.2. Cross-sectional area distribution along the complete airframe determines wave drag, largely independent of the actual shape. I agree.
is a weirdly simple rule in aerodynamics. It tells us that the ideal distribution of cross-sectional area along the length of a supersonic plane should look something like this. That includes the fuselage, wings, engines, and every other part of the plane. That's why we often see wasted fuselages that narrow to compensate for the increase in cross-sectional area caused by the wings. Planes never conform perfectly to the area rule. Fuselages and
Wouldn't it be more like this? Because, I mean, it's a lot pointier in the front. I don't know.
every other part of the plane. That's why we often see wasted fuselages that narrow to compensate for the increase in cross-sectional area caused by the wings. Planes never conform perfectly to the area rule. We need wings and engines to fly, and narrowing the fuselage over the wings isn't really an option for a commercial airliner that needs to carry people. However, carbon fiber composites do give designers much more freedom in shaping the aircraft to conform to the area rule, and Overture will likely benefit from these advances. Overture will benefit from other advances in material science that have enabled the creation of incredibly efficient engines like the GE/NX. Advances in aerodynamic modeling, metallurgy, and 3D printing have made today's jet engines vastly more efficient than the engines of the 1960s and 70s.
Guys, I'm pulling out, right? I'm so smart.
But it's important to note, one major advantage that supersonic planes cannot take advantage of: high bypass ratios. Bypass ratios have continually grown over the past 5 decades, and this has been one of the main, if not the primary driver for increased efficiency, and supersonic planes cannot take advantage of it. Supersonic jet engines need to be pure jets, avoiding the high bypass ratios of traditional airliners. The large diameter of these engines would cause an immense amount of drag, and the large quantity of relatively slow-moving air coming from the bypass would actually just slow down a supersonic jet. Instead, the engines of the Concorde
I was gonna say, I thought. I mean, oh, the whole point of a jet engine, I thought, is to be wide enough to intake a lot of air to increase. But he's saying the bisection where, like, I guess not all of the air that goes into the jet engine is consumed. Some of it kind of goes to the outer section he's talking about, and that slows the plane down.
and the large slow down a supersonic jet. Instead, the engines of the Concorde and Boom's test planes use pure jets with no bypass. These engines have not benefited from the past 5 decades of research that high bypass ratio planes have, and for Boom to succeed, they are going to have to develop an entirely new engine.
Okay, wait. So it's a good thing that... Okay, so by bypass ratio, do they mean that the amount of air that is running into the engine and being stopped, like the amount of air hitting the engine and kind of that the engine cannot consume fast enough, then that will contribute to drag. And so having the bypass areas allows you to find the sweet spot of how much area do we want for air that we're running through to just slide through, and how much do we want to enter the engine and the fuel, right?
Boom's flight demonstrator, the XB1, which is set to begin testing in 2022, is using the GE J85, an engine that has been in use since the 1950s. This simply will not do for the final passenger aircraft, and this year, Boom announced a collaboration with Rolls-Royce to develop a propulsion system for use with their aircraft. Engine development takes years, if not decades, of development. So, it will be interesting to see what Rolls-Royce can come up with before Boom's advertised first flight of 2026. It should be noted that the primary way Overture is going to reduce fuel consumption is by slowing down. Overture is aiming for a cruise speed of 1.7 Mach, whereas the Concorde cruised at 2.
Really?
Even with all these potential fuel-saving technologies,
I was expecting like
Boom
900.
rather confusingly advertises the range of the Overture at 7,866 kilometers, just 500 kilometers over Concorde's, one of the shortest routes.
Wait, so what's Mach 1.2? Like 9. No, not 890, 900. I don't know. Miles an hour?
Over the Pacific is Tokyo to Seattle at 7,651. I'm not sure whether Boom is factoring in the additional fuel capacity required by regulators to ensure planes have enough in reserve to deal with emergencies, but this is cutting things extremely close for even the shortest Pacific routes, and it most certainly is not enough for the Sydney to Los Angeles flight advertised on Boom's website. There is no doubt in my mind that we can build a more efficient supersonic passenger jet today, but I am skeptical we can build one that will succeed economically. Boom appears to be trying very hard to obfuscate the limitations of supersonic travel, and are even advertising net zero carbon nonsense about the plane being able to use sustainable biofuel, which is not only not commercially available at scale, but is vastly more expensive than kerosene. No flight operator is going to use biofuel on a plane that will already be struggling with ticket prices. The average price of a round-trip ticket from London to New York was $12,000 with the Concorde. It exclusively catered to the ultra-wealthy who were happy to pay an insane premium to save 2 hours of their day. A narrow market. A product most of us will only ever consider as a once-in-a-lifetime novelty, and that's not a sustainable business model for airlines. Without a doubt, Boom can build a prototype worthy of being the Concorde's successor, that improves on all aspects of supersonic passenger travel. But whether they can build it at an affordable price point and get fuel consumption down low enough for it to be commercially viable is another challenge entirely.
It's pretty cool. What about for like emergency scenarios, like if you want to stop a forest fire, which is the sooner you get there, the smaller the fire is, the easier to put it out. But I'm not sure if all of this is worth that. I guess just have closer planes. Yeah, so that wouldn't. I don't know.
One I'm not confident they can overcome. Overcoming challenges, to me, is the joy of engineering. That dopamine rush of solving a problem you've been working on for days, if not weeks. That feeling is what draws most engineers into their career, and perhaps you have someone in your family that gets that same joy and brilliant premium.
I did for like half a year, but then I wasn't smart enough, I realized.
Maybe the perfect gift for the ambitious learner in your life this holiday season.
Happy that there are super
Whether you're
smart
looking
people
to
like
learn
that, though.
something completely new or trying to brush up on a few topics, the best way to learn is by doing the work yourself.
I'm not trying
And
to
there's no
act
better
like I have
place for
like low
that than
self-esteem.
Brilliant.
I don't think
Brilliant
I'm
is
an idiot, but
interactive STEM
I
learning
acknowledge that
platform that helps
I
you
can't do
learn
that
concepts
sort sort
by
of
working
stuff.
through them in visual, hands-on ways. Brilliant's extensive course catalog is constantly expanding to include even more lessons that help you learn in
Thanks,
the
guys, for
best way
watching,
possible.
and really appreciate
On
any
Brilliant,
answers to my
it's
questions.
not about memorization or regurgitating facts for a test. You can just pick a course you're interested in and get started. Feeling stuck or made a mistake, you can read the explanations to find out more and learn at your own pace. Brilliant may be the perfect gift for the curious nerd in your life, or maybe you just want to gift it to yourself. You can try Brilliant for free with the link in the description or by clicking the button on screen now. And the first 200 people to sign up will get 20% off Brilliant Premium for a year of STEM learning in 2022.
Really cool video. Real engineering, awesome channel. Again, would love to see your guys' comments, especially those that could have some insight on aerodynamics, or if you've been a pilot or know anything more about this than I do, or any comments, guys. Would love to see them. Hope you guys are all doing well. Love y'all. See you next time. Bye.